In this video, we're going to go over a real-world demonstration of using Fabric for real tasks. One problem that a customer has currently is they use Tenant Cloud, which is a really great piece of software. He uses Tenant Cloud to manage his investment properties, a couple rental properties, and he's got a self-storage facility. And so having these properties, he has a property manager that when, in Tenant Cloud, they're called requests for different job tasks, repairs, things like that. And one of the biggest problems that he has is when a task is forgotten, tasks that fall through the cracks. And those are usually the small, less important, very quick little jobs. And with a property manager, a lot of bigger, more important or emergency requests come through and kind of chew up the immediate attention. And then smaller tasks that fall through the cracks, those are the tasks that become problems in terms of the interactions between the customers or the tenants and the owner and the property manager, obviously. And so in Tenant Cloud, there are all kinds of hooks or triggers for when a job request changes status. But what we need to catch in this scenario are tasks that remain unchanged, and there are no triggers in Tenant Cloud. And hopefully, the Tenant Cloud and other platforms like them, they make great software, and hopefully they'll integrate these things so that we don't have to make workarounds like this. But having to make workarounds, Fabric is an excellent tool. It makes interacting with LLMs to parse this sort of data from reports and find, locate, and pull out or extract from the reports from week to week to find these job requests or these tasks that just they persist because they've fallen through the cracks. They've fallen out of immediate attention of the property manager. And so what our task right now is we have to compare reports, find the persistent tasks. Here's some examples, example weekly reports. Now, this is not in the format of an exported report from Tenant Cloud. These are totally generic, made up, and they're semi-structured. The recurring tasks, the persistent tasks that have so-called fallen through the cracks, the things that fall through the cracks that make customers angry or irate. And so we want to start catching those. This guy wants to start catching those tasks and having them automatically reported back, on a weekly basis. In Tenant Cloud right now, there's currently no way that we've found to automatically or to automate exporting these reports either. So every Monday, the owner will be exporting a report. He'll be dropping it into his file system where there will be a trigger waiting to automatically run a program or a script that we are going to make that will compare the new data, when the exported report drops into the directory, it will compare that automatically to the prior week, the report exported from the prior Monday. And this script is written in such a fashion that, and I'll show it to you here, this script is written in such a fashion as to compare any number of reports that happen to be in that, specific directory. So this version of the script it's called stagnant tasks, and that's the -2. It just means it's version 2 of this demo, because this is just pre-production ready. It's not, it's just pre-deployment, really. So we have in this simple bash script, and this could be written in Python, and it will be written in Python. What I've been waiting on is to see if the guys that are running the repo here, the Fabric repo, if they end up coming out with a Python library that allows for the Fabric tool to be used programmatically within Python, because I'm just trying to stay out of the way the best that I can with these guys. And so if I don't see anything soon, I'll probably I'll write a library so that the Fabric tool can be used programmatically in Python code. And the reason for that, not just using bash, is because this script here would need a rewrite to work in PowerShell. This is meant to work in bash. And the reason for making a Python library would be because whatever type of system you have, the Fabric tool will, once it's installed and set up or calibrated, it will be ready to use with however your system is set up. So that in Python, running the Fabric tool through, for instance, the sub-process library, it would call the Fabric tool on the command line via the command line of whatever your system is, and the Python library won't have to account for either PowerShell or Z Shell or Bash. It can just find and call the Fabric tool, and then the Fabric tool installed on your particular system will then take care of the rest. That's one way to keep the coding streamlined in Python. And so whenever that occurs, whether it's the guys in the repo or if I end up doing it, whichever is just fine. I'm just kind of waiting it out a little now that I'm having to use something like Fabric in a real world production environment to solve problems. And so just to go back to our example use case here, we have 4 weeks of exported reports. These are just for demonstration purposes. So I simulated exporting the report data in a CSV format, with the columns here. That makes it a little easier on the LLMs. I also have a version where this data is very junked up, and I still got the script to work using certain models. Now, using OpenAI API keys, OpenAI and ChatGPT, whatever model you select from OpenAI to sync with your Fabric tool and then run this script here, it works pretty flawlessly. And to make sure they work, we go through a lot of testing on a local system with local LLMs. I'll show you what happens when you use some of the other models that are really good models, but they just can't seem to handle the reasoning load that's put on them. And running through, there's a couple models that nearly nail it, but there's one model that nails it every time, and naturally that would be DeepSeek, and it's the 8B model. The 7B and the 1B just don't quite cut it. The 8B and above, they really nail this task, this reasoning task. Then what happens, and you'll see what happens with the DeepSeek models, is that no matter how you try to restrict its output in the Fabric pattern, it really doesn't follow the instructions well in terms of keeping its response concise. It responds with a lot of its thinking processes. And so then you can run it back through. You can take those reports, and this will all be clear. It'll take those reports the local model DeepSeek generates, and then I've used Llama 3.2 3B to give it clean output. All this will be clear as we go through the demonstration here of using Fabric in the real world. Now, the overall project won't be outlined here. I've kind of zoomed in on just the task of parsing the data in the 4 reports and comparing the data to find the persistent tasks that have unchanged status. And for our eyes, it'll be the 500s, 502, 512, 513. Those are the tasks so that you and I, can see which ones persist. And so there's the task ID, the description, and the only other one that really matters is the status. And you'll see like 502, for example, follow up on late rent payment, and it has a status of pending. Over here in week 2, it still has a status of pending again and again. In the 3rd and 4th weeks, it has a status of pending. So that is a persistent task, meaning it's a stagnant task. It's a task that fell through the cracks. Some of the other ones, 512 and 513, those are the ones we want to keep taking a look at. They're both pending in weeks 1, 2, and 3. And then in week 4, to change it up, I had 512. I had the status listed as completed. And so on the last generated stagnant report or missed task report, we should have, of the final one of the 3, there will be 3 comparisons, comparing week 1 and 2, week 2 and 3, and then week 3 and 4. So those are 3 generated reports that we're going to create. And the last one, comparing week 3 and 4, should only respond with 502 and 513, where they are still pending. 512, which then becomes marked completed in the exported report of week 4, that one should not be reported as a stagnant task or something that fell through the cracks. So this is the script, a very basic, the one for production, the one that's almost ready for deployment. It's a little different than this. This one is kind of one of the very first iterations just for testing to get all of this functionality working. For instance, there will be a dedicated directory, not the present working directory that this script will run in. Here, the pattern that we select to run in the Fabric command, the reason that you're going to start seeing the numbers here first is because when we are visiting our patterns in Ranger here, if we just go into the patterns directory, you'll notice that if you put numbers before your custom Fabric patterns, the patterns that you create yourself or that we create ourselves, if you put numbers or symbols and things like that at the beginning of the pattern name, when you go into the Fabric pattern directory to look at, place, edit, delete your patterns, they'll always come up at the top. So, if all these 200 some odd patterns that come with the Fabric tool, if you want to be able to easily find yours, if you just place a number ahead of it, number 1 with 4 different versions or iterations, that's for a separate project altogether. Number 2 is 02.1. This is an initial Fabric pattern, an instruction set for the LLMs when they're comparing 2 reports at the same time. This is the first iteration of that, and then I refined the pattern. So if we just go take a look at it, if we refine the pattern, this being the initial pattern, just to give you a quick, the intent and purposes, and we followed a very generic structure of a Fabric pattern. We filled out the intent and purpose section, then the steps to take, and then the output instructions, and then you end it with an input section where the system message indicates that anything after input would then be the user message. And so version 2 is just a little more refined. It has basically the same intent and purposes section, and so we just added or refined the steps for the model to take in this second version. And if you're really interested in this specific demonstration of the Fabric tool, feel free to pause the video. And we added some output instructions, and this was because of the output, the extended output that we get from the DeepSeek model, and it still didn't quite follow the instructions to only respond, and you'll see what all that means here. And then we just use a simpler model to clean up the response, and I'll show you how to do that. It's all really, really simple using the Fabric tool. A lot of this stuff can be done with longer, like you could use various other command line tools. It's just that the Miessler Fabric AI command line tool, the way it's designed to allow for specific control of system prompts or system messages, it's what makes it so valuable in manipulating these LLMs that we're using to give us exactly what we want, to have them perform the exact task and to give us the exact output or responses that we're looking for so that we can then do something with that data. The Fabric tool is just so far, it's just, far and away the best tool for the job that I've discovered. That's one of the reasons that, backing up and getting back into the workflow here, it's one of the reasons that you'll be seeing the numbers here. It's only because by prepending the name of the pattern that you give it, it just puts it to the top of this directory, so they're easy to find. You find them right away. So going back to this, that's what that's all about right there. And then this scripting, if you really wanted to see what all this does, you could just take it, put it into ChatGPT, or if you have a code model locally, you could put this right into the Fabric tool in your local model and ask it to explain this code step by step what it does. This is just bash scripting. It's all pretty simple. Setting up these variables, it's because we're comparing 2 reports at a time. So what it needs to do is it needs to save the previous report, load the new report. It combines them together into one body of text, separated very clearly in that body of text with 2 different labels, what they are. One's a previous report, one's a current report, for the LLM to know what it's comparing against. against. So that's where it echoes into one body of text called the combined report. It starts out using Markdown, because Markdown is something that LLMs seem to understand very well. It takes the first report of the two that are being compared, and it sends out a header saying previous report, and then it throws in the first of the two reports, and then it proceeds with a couple empty lines and a new Markdown header of current report, which is the second of the two. It spits that out in that order with those headers or labels into the combined report. And then you can see right here, it cats the report, pipes it to the Fabric pattern. The pattern used is this pattern set in this variable right here. And then it outputs it to a file, and all of this stuff here, normally you would just put -o and then the name of the output file. All of this stuff just dynamically names it. That's all that's really doing. And then at the end of this script, it's shoving data around and cleaning up anything that the script has created, like the combined report. It just does a quick forced removal of the combined report so that it doesn't start junking up this directory. And all of this will change in terms of a production-ready script. And in the very near future, if I don't discover a Python library to use the Fabric tool programmatically, then I'll write one, and then I'll export that new library to PyPy or wherever, so that anyone that wants to use it. And I'll probably name it something other than Fabric. I'll probably name it MFab or something like that, because MFab, Miessler Fabric, that's what I call the tool all the time. I call it MFab or Miessler Fabric, because when you Google or search for Fabric AI, there a couple other things also always pop up. The Microsoft has some sort of Fabric AI content. I think there's at least one other Fabric that's AI related. And so when you're Googling or when you're searching for this Fabric framework, if we take a look, if you were looking for this repo, if you search for Miessler Fabric, you will go basically straight to this repo. And so I always, when I'm talking with people, I always say Miessler Fabric or MFab, because it really clearly points to this Fabric repo. If I end up creating a Python library to use Fabric programmatically for scripting and solving real world problems, I'll name it probably MFab, so that if these guys do come out with a Python library and they name it Fabric AI or the Fabric pattern framework or whatever they end up calling it, that mine won't be in their way. Then if they do it, then I'll just remove mine, so there's no sense in two different groups maintaining a code base that does the same thing. If they come out with a Python library to use their tool, mine will come right down. So getting into it, we've taken a look at, real quick, these 4 weeks reports exported every Monday, once a week for 4 weeks. We have our few persistent or stagnant or forgotten tasks. One of them has changed status, so the last week it shouldn't list confirm property insurance renewal. It should only list follow up on late rent payment and check exterior lighting timers. And all of this is simulated data, so as not to reveal real world data, who they are, what kind of problems they're having. It's just keeping their information private. So I simulated these 4 weeks, because this by no means is a representative of exporting a report from Tenant Cloud or any of that other software. These are completely fabricated reports. So we have, to run through this tool real quick, we'll take a look. I have them in this directory here. I have report 1, 2, 3, and 4. Those are 1, 2, 3, and 4. I have this script right here, stagnant-tasks-2. I have that in a bin directory. We'll take a look at that. Is in a bin directory that we had set up, and there's a bunch of other projects, nothing to worry about. There's stagnant tasks, and this is stagnant tasks 2. And this, again, this was just the first version. This is the second version that we're using, and these are in the bin folder so that we don't have to type // or full paths. They're called upon upon just like any other system tool. So that's where we have the script placed, just so you can see that. And so we would run on the exported reports that have landed in this directory. Let's say that reports 1, 2, and 3 were already in the directory and report 4 landed. Monday came around and the report was exported from Tenant Cloud or whatever other type of platform or software that you're using to maintain your investment properties or to keep up after the data and things like that. Job requests, submitted requests from customers that notice things broken or that are keeping them from using whatever it is they're leasing from this guy properly. Let's assume that report 4 just landed. Real quick, this is what is going to happen in the real world use case of this. So every Monday, a report will be exported and it will land in a directory that won't be called Fabric Demo, and then structured is because I have 2 different types of data, structured data and then unstructured, where I have it a mess, and we'll go through that just so you see the capabilities of these things. And so what will happen is the user, the client, will be exporting the report, downloading it and putting it into a specified directory with a hook or a trigger, where when the system, and this could be done with Python too. Python has, I think it's called Watchdog maybe. I'm pretty sure it's Watchdog or some other libraries like that. When it sees a new file or any specified change, whether a file was modified or deleted or created, as in a new file lands in there, and then it will engage a script or a program. And you can also do that in the environment that you're using, like Bash. I have to assume, I know Z Shell would have it, and I have to assume PowerShell would have it. That's where moving over to Python will be nicer, because then it's one script no matter your platform. But in Linux, a Unix-like environment, there would be a system trigger that when a new file lands in the directory, it will engage the script stagnant tasks. Let's assume that report 4 landed, the trigger happened, and it's going to call up, instead of us typing this, it would automatically call it up. Then we would run it, which we'll run it in just a second. What this real world overall program, we're looking at part 2 of this, of a 3-part project. The third part would be, for instance, using email or using, signing up and getting a United States phone number from Twilio, where the LLM can then, with its output, send a text message to the owner or the property manager, send a text message right to their phone about tasks that appear to have fallen through the cracks. They appear to have been forgotten about and are very, very likely to make a customer or tenant irate or, very not satisfied. This has been a real problem, and that's why we're using Fabric to solve this problem in the real world. We are first going to make sure that our Fabric tool has DeepSeek, because I've run this with plenty of other of these models here. I've used 3.2, I've used Intern LM 7B, almost did it, but not reliably. It didn't get a 10 out of 10 on its results. 7B got, I think that achieved like 8 out of 10, but twice out of 10 trials in a row, it only got 7 out of 10. 8B, DeepSeek 8B and 14B. This is DeepSeek R1. The 8B and 14 models, they got 10 out of 10, 10 in a row. I wasn't going for 10 out of some number. It had to nail this task 10 times out of 10 times for me to consider it. And so we're going to be switching and make sure that we're on number 9, and we'll use the default context length. We're in this directory. We're pretending that the report number 4 just dropped, and the system trigger has found that there's a new report in the directory, and so now it needs to run the stagnant tasks script on any reports, any and all reports that are in the directory. So if the user were to delete old reports, it wouldn't be comparing those. So that, you might only want to keep a certain number. And there's a very simple script already in production. It's not deployment ready for the user to have a simple, clean, graphical user interface for managing the reports that are in this directory without having to go in the command line. So we have made sure that we're using DeepSeek 8B, and we're going to run this. So we have the first response, and this is what DeepSeek does. It starts with this opening tag of thinking. No matter how I've tried to limit it with its response, its output instructions, it still outputs this thinking tag and then all the thinking that it does. and then it has a closing tag, and then it gives the summary. And this is all we want. And so we have, for this real world use case, we have these responses being piped to another Fabric command where it uses a much simpler model. It's actually working very well with Llama 3.2 and a bunch of others, and it cleans this up, and I'll show you what that looks like. And so we have all three responses. It's ran a comparison on reports 1 and 2, reports 2 and 3, and then reports 3 and 4. And you see it has these big bodies between these thinking tags. And then this is the response it gives. And so it's first comparison of report 1 and 2. It nails it. It's anything labeled 500. It nails the tasks that have remained unchanged in their status. You know, it's the status right here that matters. You can have the same task and description, and if the status changes, there's already triggers built into, for instance, Tenant Cloud. There's already triggers built in for when something changes status. What there is not is something feasibly more important, which is anything that has not changed status and still persists week to week. Those are the things you want to find, and none of those things are automated. And so that's what we're doing here. Again, that's the problem that we're solving, the real world problem, and it's very much a real problem in this scenario for this guy. And so it correctly gets the three tasks that persisted from report 1 to 2, and with the status unchanged, then this thinking tag and the end thinking tag again. And you can see sometimes it's DeepSeek's a very interesting model, but at any rate, getting to the end of it, it correctly finds again the three tasks that persist and have unchanged status. And it even outputs these tasks are flagged, potentially needing attention, etc., etc. And then it goes on to the last comparison of weeks 3 and 4. And we get to somewhere the end, the slash think, that's the end tag. If you're familiar with HTML or anything like that, you'll notice that kind of format. And then see, if you remember, we changed the status on this item here. We changed it from week 3 pending, and week 4 we changed it to completed. So it shouldn't flag this one as persisting and possibly forgotten. It should only be listing follow up the late rental payment and checking exterior lighting timers. Those are the forgotten tasks that we're hoping it finds. And it's exactly what it finds. So DeepSeek of local models. Now remember, using OpenAI API keys, ChatGPT or whatever models that you're using through OpenAI, they nail this very well with clean output one step. If you're using local models, of all the models I've explored, 20, 30 plus models, DeepSeek is the one needed for, and again, this is models around 8B and lower, or 12 or 14B and lower, billion parameters. You get up into much, much larger models, and I'm sure just about anything would handle this. But in terms of consumer grade hardware and to make sure that our fabric patterns are really well dialed in, if a fabric pattern works with a local model of 8 to 14B on down, then we know that pattern is going to work with any models that are more capable. It's almost a certainty. And so that's why we do this local testing. So back to our task, we find that in the final comparison of reports 3 to report 4, it finds that there's only 2 persistent tasks because one of them, the status changed from pending to completed. And so this successfully does it using the Fabric tool and Fabric patterns so that we can automate, we can iterate through files programmatically with the same instruction set. That's what Fabric makes really, really easy and awesome. And then we find this data that normally has to be parsed through. Now imagine going through with your eyes and imagine that this isn't so well organized, or the numbers are jumbled because there's tasks from various weeks and they don't get renumbered. So everything's like 100 something. And all of a sudden you have to print this out, and you have to bust out a highlighter if you're going to do this via your own effort. This is the type of data that's pretty hard to parse. It's easy to miss things. It's easy to miss these tasks that we're looking for. Computers and LLMs, they don't miss these things if they're tuned up right for this specific problem. And So what we will do is we'll go up anytime we see this written to output. That's the end of one comparison of reports. So we'll take like the final one here where it's comparing week 3 to week 4. All the thinking, we're going to pretend that we just automatically piped this or sent it to a new Fabric command to clean it. So we'll take all of this, we'll copy it, clear our screen, and then programmatically we would normally do this, but let's switch our default. Let's switch, let's just try it with Llama 3.23b 37. And so now we can run, we copied one full response from the DeepSeek model. That'll be being pulled into this command with the PB paste, piping it to Fabric with an inline instruction to say respond only with the unchanged tasks with a clean output response. We now have the Fabric tool temporarily hooked up to the Llama 3.23b model, streaming the pattern. We're just using raw query. Now again, in production, we would probably want a specific Fabric pattern for this. But for demonstration purposes, we can cut some corners. And so you'll see here that with this simple inline instruction with the raw query pattern and exploring the raw query and the AI, those two patterns are for a chat box like interaction. And so they're very good for these quick inline questions or statements or instructions. And so it just parses all of that data that's in PB paste. Now the lesser models are able to handle the reasoning task, which is to only output the final unchanged, meaning the stagnant tasks. And you can see in this output, we could also do, if you had Glow installed, just like with sudo apt install Glow, we could do this response and pipe it to Glow. And then we get a much cleaner output. Glow, just because the models, the Fabric patterns usually instruct the models to output in Markdown, when it responds in Markdown and then you pipe it to Glow, Glow is an in-terminal Markdown, kind of a Markdown renderer. It can't change the font size, so it just highlights any headers and does a nice formatted bullet output. This is the correct response from using the Fabric tool programmatically to find stagnant or forgotten tasks from once weekly downloaded reports. And it accurately does it. It accurately performs the job. Again, in the full project, there will be an initial module of the project. This here that we walked through, actually using the Fabric tool to find these stagnant or forgotten tasks. That's the second module or phase of the overall project. And then the third module that we haven't gone through here, only because I haven't cleaned or privatized the data yet. I have to set up on my own a Twilio account to show you, and then screencast from a phone to show you how the output from this would programmatically be used to send a text to the pertinent people about the forgotten tasks or the stagnant tasks. So the first part would be when the client exports a report from their cloud platform like Tenant Cloud. Tenant Cloud's one of the best. When they export the report and it lands in the correct directory, the system, and in the future it'll be Python or something like that, but the system detects a change in the directory. It detects a new file, and so it will automatically run the stagnant tasks script. That's the first part. And whenever the time comes, I can absolutely do a quick video on that, but I highly doubt that you have rental properties and mini storage, self-storage units. So that's kind of why I didn't take, because they choose up a lot of time to go through and demonstrate this. So I left the first of 3 parts out, which is the programmatic hooks or automatic actions that the system will take when it detects a new report in a specified directory. Then this being the second phase of the project is what's important in terms of this is what uses Fabric. And then the third phase, again, would be taking this report that is spit out via Fabric and then programmatically texting it or emailing it to the people that need to see. These are the things that are being forgotten or falling through the cracks or otherwise, for various reasons, have become stagnant with their status unchanged over a period of weeks. So it's a pretty interesting use case. It is very, very specific, very niche, but you can start to see how you can use Fabric to solve just about anything. Now, if Tenant Cloud and other platforms like that, if they start to provide API integration and for automation, they provide actions for things that do not change. That's a very important thing in this specific situation. Real world, it's definitely important because these are the things that cause problems. When something doesn't, when a status of a request doesn't change, that's one of your biggest problems, and it's not accounted for. And so with a very, small amount of code, there's maybe with all the comments, there's 50 lines of code, basically. It's not a lot. 45 lines of code with all the empty lines and all of the comments. It's probably like 20 lines of code for this second phase for using the Fabric tool. And again, this is in Bash and with these reports. And what we can do real quick is we'll clean up our terminal, coming back to the real demonstrations of this. I have the structured data and I also have unstructured. So let's take a look at these. And to keep it clean, I'll come over here. Okay, so now I've pulled up for the unstructured. It still has the data, but you see how it's not clean. The data hasn't been cleaned. And in an exported report from something like Tenant Cloud, it will pretty much be clean data. It will be in a structured format. But here you can see we have task 101, task 102. They're not even of the same exact format. This one doesn't even have the tasks listed, the task ID listed, but it still has a description. And we have the status in different formats. We have the dates, and all these things are going to really confuse LLMs, and that's kind of the purpose of this little test. And I haven't actually run this yet. We're going to be doing this, together here for the first time on this set of data. I've done it on real world data. I haven't done it yet with this fabricated data. And so we will see that we have, let's take a look real quick. The late rent is listed here as task 102, and up here it says still pending instead of pending. But the late rent follow-up down at the bottom, insurance renewal, and the lights exterior check. This one says exterior lights check. It's changing the description, but they're all those three are still pending. And over here, the insurance renewal and the exterior lights check. And do we even have the late rent again as a question? Has them all three pending. And over here we have late rent. It doesn't even say pending. It says unresolved, and it's all constantly in a different format. This is like what you call junk data. This is garbage data, but the actual data is still hidden in all of this unstructured representation of it. So all three of them are persistent. I changed this one in the structured example, but let's just leave all three of them pending or unresolved, or all the various ways that that's described. And let's see what DeepSeek does with this. First, and there's ways to programmatically do this. You don't have to manually go and do this. And we're going to go over, when we get back into our Fabric videos, on using the tool, how with a command, you can specify momentarily a different model, or you can change the default model at the command line using the tool. You don't have to go into setup. All of that's going to be very well and clearly and cleanly displayed or demonstrated and explained. You won't have to do any of this. This is just because I'm showing you in real time how I test these things when I'm using this. So we're going to go back to number 9, make sure we're using DeepSeek. And we are in the unstructured directory with the junk data, where there's still real data in it. So say instead of exporting a clean report from solid or stable software like Tenant Cloud, you have someone just manually inputting things that they think of, or that they're reading off a list, and they're inputting it digitally and they're not putting it in cleanly. Can this handle it? Let's see. Let's see how DeepSeek does with it. So here on the first response, in the summary, in the unchanged stagnant tasks, it has one listed as completed, only because it recurred, but its status did change. And it notes that the status changed from pending to completed. So in the summary, it had it right. And then in the final, it lands it. It gets it correct. And so if we were to take this last response, again, we copy it using the Fabric tool. If we go back to the Llama 3.23b model, just to we can use a lesser, cheaper, or less compute intensive model to parse the data. We could run, now that we copied the response, we would normally pipe it or send it as a file, PB paste to Fabric, And we don't even need to do streaming. So let's try and send it right to Glow. And we get a really nice output here in the terminal. And this would be really nice output to send in an email or in a text message, for phase 3 of this project, which doesn't have a lot to do with Fabric. It has to do with other tools to solve these real world, very very serious problems that this one person has. These tasks being forgotten or slipping through the cracks week after week, and then you get that irate customer blowing up your phone or blowing up your inbox over these things that have been promised, and they keep slipping through the property manager's fingers. This gives us really, with a simple command, programmatically, and you never have to see it. And now what's even more important or more useful is that all of this functionality, this being sort of phase 2 of this 3-phase real world project, all of this would be wrapped up and made into a clickable icon in a desktop environment. So like right on the desktop, there would be an icon, kind of like a shortcut in Windows to running a program. This whole thing would be run to a shortcut, and that would be to run it on purpose. You got to remember, phase 1 of this project is designed to detect all of this, to detect a new weekly report being inserted into a specific directory. And then all of this would happen automatically if there are unchanged or forgotten or stagnant tasks that are on these lists that are just very laborious to get through with your own eyes, because of the way that CSVs and all these things, the way they look to the eye. It's just so easy to overlook these things unless you're going through and highlighting them. This nails it. If I've been getting, for the most part, like a 10 out of 10 response rate from DeepSeek, and then cleaning it with any of the other smaller models, cleaning the output with this part here, and then visually cleaning that output in the terminal with something like Glow. And there's various other things that you could use, but the PB paste is what's taking the DeepSeek response, which is very verbose. No matter how you try to restrict it in your output instructions of your Fabric pattern, it just has that body enclosed in the think tags. It always outputs that, and so it's very simple. Doing it manually, yes, there's a whole other step that you have to type in, but all this can be done programmatically, so that you're doing it once in this, and then you would have another script, very short, that just runs this through the cleaning part of the process, which is just running all of this. And then the output would go to phase 3, which is sending this clean data right here, sending this data either via email or text message or whatever notification system you want to use. And remember, to send text messages, your email accounts can be very junked up, but a text is something most people get and they look at immediately. And you can do that via Twilio, which ends up being like $1 a month. If you sign up for a year, I think it's $1 a month, $1 a month to have a United States phone number, or whatever country you happen to live in. $1 to keep the same number for your system to send out a text to a number. It's just too stinking easy. It's too easy to solve these problems. And, we're just now able to solve these problems like this. Yes, if you totally sanitized your data, you could have static scripting solve some of these things. But man, if you have any variation in your data, it's unusable to use static scripting, but not anymore. Not with LLMs and not with Fabric AI. You can have variations, you can have some errors here and there in your data, and with the right model, again, this is using testing on local models, on system models that are not nearly as powerful as models that you buy API credits for. Those nail it. They really nail it. You wouldn't have to do this cleaning phase. You could just have in your Fabric pattern, I need this clean, and it will send one step. It'll send you this nice and neat. It's a beautiful thing. So I hope that was helpful. As I made a couple, 2-3 Fabric videos, YouTube videos, showing a quick overview, showing installing the binaries and using aliases, or inserting the Fabric tool into your path, so you call it like a system tool, which is what you see here. That's not using an alias. That's with the Fabric tool inserted into a directory that's in our path. I went over that, and then I think the next video was installing Fabric using Go, and then cloning the repo. Making those videos and showing it to a couple people that I thought locally around me that it would be useful to. And they'd say, use this thing in front of me, use this thing in front of us. And so, you know what? I have something that popped up probably the day before. I said, I can fabricate some data, but I can recreate the problem that this one person has that came to me. And I can walk through basically breaking the project up into phases so that I can zero in on the phase that uses Fabric. And this is it. This is how it's done. This is using Fabric in the real world. And this didn't take long. This normally, I can't really imagine what would have been the charge on doing this with static scripting, static programming, just 2 years ago, 1 or 2 years ago. This would have been, for a small time guy, that just has a couple rentals, one mini storage, not so small time, but you know what I mean, in the grand scale, in the grand scheme of things, this isn't a Fortune 500 company that's coming to me with a problem. This is a guy that has a couple small businesses and he's got a problem. And in times past, it would not have been realistic for him to have a software or data problem like this solved in like an hour. There's a couple days that are going into this, but it's only like 1 or 2 hours each day to get to deployment, because we have these fantastic LLMs both in the cloud via APIs or locally, and then something like Fabric, Miessler Fabric, to programmatically on the in scripting or via the terminal, the command line, or in a script, inside this script, using Fabric programmatically to solve problems, to dynamically, this script could be to solve any problem that needs interaction with LLMs, especially iterative action or iteratively comparing things like reports using the same Fabric pattern or stepping it out. Maybe there's some reason to use 3 or 4 different Fabric patterns to solve a problem over one body of text like a report, or many inline, comparing them or going through them sequentially. Anything you can think of that can be solved programmatically has now been made orders of magnitude more powerful and orders of magnitude easier to create. This whole thing, as simple as this looks, this all blows me away that I'm able to do this stuff so stinking easily. It's unreal. And it's kind of exciting. We pretty much nailed this. If I were to run that again over and over, you'd see apparently it missed one thing on one of the week comparisons. But the thing is, this is a functionality that the cloud software the customer's using doesn't have this ability. So, if it gets one thing wrong out of 100 tries, this thing has done its job. It has basically made the owner and the property manager aware of things that are slipping through their fingers, the things that make customers angry and create problems for their day-to-day operations. That's what we're solving, and we did this pretty easy, and whatever your problem is, you could take this script right here and copy it, put it into ChatGPT as an example, and then say, as an example, and then give it your problem and have ChatGPT or using Fabric with local models or Fabric with OpenAI API keys with some sort of coding model, and have it start solving your problem and start iterating through a script and have it writing the script for you if you're no good at scripting, or if you don't want to learn it. It's not very hard, by the way, but just to get you started on solving your own real world problems, or taking this whole example and taking it to your local tech guys and saying, here's how I want you to solve the problem I have, and now here's the problem I have. And a tech guy, if he's not just a hardware guy, if he's into the software end of things, he'll see this example and he'll know exactly what to do. If he has any questions on the Fabric tool, he or she has questions on the Fabric tool. That's what the core videos about Fabric AI are about. This is why you should be interested. This demonstration, the why, the how, that's the other videos that I guess would then be more interesting for people to seek out now that they see the why. There's a couple other demonstrations that I guess now I should really go through with you. And so I will create those videos the best I can, creating fabricated data, all that stuff. It gets a little cumbersome. But if the why is what's going to get people using this Fabric tool, then the Miessler Fabric tool, then, I'll have to do it, because, man, you can solve some problems. I can't even imagine how difficult and laborious this would have been before having LLMs and before having the Fabric AI pattern framework. Miessler has he's done all of us a service here, and especially open sourcing all of this. This is cool. This is nice. This is awesome. So we'll see you on the other side.